acids, bases, and salts. Solution used in daily life like sour fruit juice, lemon juice, tamarind water, buttermilk have acidic nature. The acidic nature of aqueous solution is due to acid in it. An aqueous solution of salt has a neutral nature. The neutral nature of an aqueous solution is due to the salts in it. The aqueous solution of baking soda and washing soda has a basic nature. The basic nature of aqueous solution is due to the bases in it. Acids are sour in taste and change the color of blue litmus to red, whereas bases are bitter and change the color of the red litmus to blue. The process of neutralization between acids and bases forms salts. Litmus is a natural indicator. Turmeric is another such indicator. You can also use synthetic indicators such as methyl orange and phenolphthalein to test for acids and bases. Understanding the chemical properties of acids and bases. Acids and bases in the laboratory. Pour the solution of hydrochloric acid on 4 watch glasses. Then add red litmus solution, blue litmus solution, phenolphthalein solution, and methyl orange solution to these 4 watch glasses respectively. Red litmus solution does not change color. Blue litmus turns red. The solution becomes colorless in a watch glass coated with phenolphthalein, while the solution turns red in a watch glass coated with methyl orange. Similarly, adding these 4 indicators to a watch glass with a solution of sodium hydroxide, the solution of red litmus turns blue. Blue litmus solution does not change color. The color of the solution turns pink in a watch glass coated with phenolphthalein, and the solution in the methyl orange tipped watch glass turns yellow. Changes adding indicator to different solution. These indicators tell us whether a substance is acidic or basic by change in color. There are some substances whose odor changes in acidic or basic media. These are called olfactory indicators. Vanilla, onion, and clove can be used as olfactory indicators. How do acids and bases react with metals? Activity. Take about 5 ml of dilute sulfuric acid in a test tube and add a few pieces of zinc granules to it. You can see air bubbles on the surface of zinc granules. Pass the gas being evolved through the release tube in the soap solution. Bubbles formed in the soap solution. Take a burning candle near a gas-filled bubble. The candle burns with a blast as there is a combustion of hydrogen gas. Repeat this activity with some more acids like HCl, HNO3 and CH3COOH every time a burning candle burns with a sound. The metal in the above reactions displaces hydrogen from the acids. This is seen as hydrogen gas. The metal combines with the remaining part of the acid and forms a compound called a salt. Thus, the reaction of a metal with an acid can be summarized as acid plus metal gives salt plus hydrogen gas. In the same process, using a solution of sodium hydroxide instead of sulfuric acid, the candle will burn with a similar blast. How do metal carbonates and metal hydrogen carbonates react with acids? Take 2 test tubes, label them as A and B. Take about 0.5 gram of sodium carbonate in test tube A and about 0.5 gram of sodium hydrogen carbonate in test tube B. Add about 2 ml of dilute HCl to both the test tubes. Pass the gas produced in each case through lime water. The reactions occurring in the above activity are written as test tube A. Na2CO3S plus 2HClAq gives 2NaClAq plus H2OL plus CO2G. Test tube B. NaHCO3S plus HClAq gives NaClAq plus H2OL plus CO2G. On passing carbon dioxide gas evolved through lime water becomes milky in color as it produces a white precipitate of calcium carbonate. CaOH2Aq plus CO2G gives CaCO3S plus H2OL. Lime water passing through large amount of carbon dioxide becomes colorless as it produces calcium hydrogen carbonate, and the calcium hydrogen carbonate produced by this process dissolves in water. Limestone, chalk and marble are different forms of calcium carbonate. All metal carbonates and hydrogen carbonates react with acids to give a corresponding salt, carbon dioxide and water. How do acids and bases react with each other? Take about 2 ml of dilute NaOH solution in a test tube and add 2 drops of phenolphthalein solution. The color of the solution will be pink. Add dilute HCl solution to the above solution drop by drop. The solution appears to be colorless from pink. The reason for this color change is the neutralization process in which the bases are eliminated by the acid. Now add a few drops of NaOH to the above mixture. The pink color of phenolphthalein reappear. In this activity, we have observed that the effect of a base is nullified by an acid and vice versa. The reaction taking place is written as NaOHAQ plus HClAq gives NaClAq plus H2OL, which is base plus acid gives salt plus water. The reaction between an acid and a base to give a salt and water is known as neutralization reaction. Reaction of metallic oxides with acids. Activity. Take a small amount of copper oxide in a beaker and add dilute hydrochloric acid slowly while stirring. The color of the solution becomes blue-green and the copper oxide dissolves. The blue-green color of the solution is due to the formation of copper chloride in the reaction. The general reaction between a metal oxide and an acid can be written as CuOS plus 2HClAq gives CuCl2Aq plus H2OL, which is metal oxide plus acid gives salt plus water. Metallic oxides are said to be basic oxides because they are processed with water to form bases. Metallic oxides are basic in nature. Reaction of a non-metallic oxide with base. You saw the reaction between carbon dioxide and calcium hydroxide. Calcium hydroxide, which is a base, reacts with carbon dioxide to produce salt and water. Since this is similar to the reaction between a base and an acid, we can conclude that non-metallic oxides are acidic in nature. What do all acids and all bases have in common? All acids have similar chemical properties. All acids generate hydrogen gas on reacting with metals, so hydrogen seems to be common to all acids. Let us perform an activity to investigate whether all compounds containing hydrogen are acidic. Activity. Take solutions of glucose, alcohol, hydrochloric acid, sulfuric acid, etc. Fix 2 nails on a cork and place the cork in a 100 ml beaker. Connect the nails to the 2 terminals of a 6-volt battery through a bulb and a switch as. Now pour some dilute HCl in the beaker and switch on the current. The bulb begins to glow. Repeat the experiment separately with dilute sulfuric acid, glucose and alcohol solutions. The bulb will start glowing in the case of acids, but you will observe that glucose and alcohol solutions do not conduct electricity. Glowing of the bulb indicates that there is a flow of electric current through the solution. The electric current is carried through the solution by ions. Since the cation present in the acids is H+, this suggests that acids produce hydrogen ions, H plus Aq in solution, which are responsible for their acidic properties. Repeat the same activity using alkalis such as sodium hydroxide, calcium hydroxide. The bulb will illuminate the OH- ion in the base, which are responsible for their basic properties. What happens to an acid or a base in a water solution? Activity. Take about 1 gram solid NaCl in a clean and dry test tube. Add some concentrated sulfuric acid to the test tube. There is a gas coming out of the delivery tube. The resulting air has no effect on the dry blue litmus leaf and the wet blue litmus leaf turns red. This experiment suggests that hydrogen ions in HCl are produced in the presence of water. The separation of H plus ion from HCl molecules cannot occur in the absence of water. HCl plus H2O gives H3O plus Cl-. Hydrogen ions cannot exist alone, but they exist after combining with water molecules. Thus, hydrogen atoms must always be shown as H plus or hydronium ion. H plus H2O gives H3O plus. Acids give H3O plus or H plus Aq ion in water. What happens when a base is dissolved in water? NaOHS plus H2O gives Na plus Aq plus OH minus. KOHS plus H2O gives K plus Aq plus OH minus Aq. Bases generate hydroxide ions in water. Bases which are soluble in water are called alkalis. Now, as we have identified that all acids generate H plus and all bases generate OH minus, we can view the neutralization reaction as follows. Let us see what is involved when water is mixed with an acid or a base. Activity. Take 10 ml water in a beaker. Add a few drops of concentrated H2SO4 to it and swirl the beaker slowly. Touch the base of the beaker. There is a change in temperature. The process of dissolving an acid or a base in water is a highly exothermic one. Care must be taken while mixing concentrated nitric acid or sulfuric acid with water. The acid must always be added slowly to water with constant stirring. If water is added to a concentrated acid, the heat generated may cause the mixture of splash out and cause burns. The glass container may also break due to excessive local heating. Look out for the warning sign on the can of concentrated sulfuric acid and on the bottle of sodium hydroxide pellets. Mixing an acid or base with water results in decrease in concentration of ions per unit volume. Such a process is called dilution and the acid or the base is said to be diluted. How strong are acid or base solutions? Acid-base indicators can be used to distinguish between an acid and a base. We can do this by making use of a universal indicator, which is a mixture of several indicators. The universal indicator shows different colors at different concentrations of hydrogen ions in a solution. A scale for measuring hydrogen ion concentration in a solution called pH scale has been developed. The P in pH stands for Potenz in German, meaning power. On the pH scale, we can measure pH from 0 to 14. pH should be thought of simply as a number which indicates the acidic or basic nature of a solution. Higher the hydronium ion concentration, lower is the pH value. The pH of a neutral solution is 7. Values less than 7 on the pH scale represent an acidic solution. As the pH value increases from 7 to 14, it represents an increase in OH- ion concentration in the solution, that is, increase in the strength of alkali. Generally, paper impregnated with the universal indicator is used for measuring pH. The strength of acids and bases depends on the number of H plus ions and OH minus ions produced respectively. If we take hydrochloric acid and acetic acid of the same concentration, say 1 molar, then these produce different amounts of hydrogen ions. Acids that give rise to more H plus ions are said to be strong acids, and the acids that give less H plus ions are said to be weak acids. Bases that give rise to more OH minus ions are said to be strong bases, and bases that give less OH minus ions are said to be weak bases. Importance of pH in everyday life. Are plants and animals pH sensitive? Our body works within the pH range of 7.0 to 7.8. Living organisms can survive only in a narrow range of pH change. When pH of rainwater is less than 5.6, it is called acid rain. When acid rain flows into the rivers, it lowers the pH of the river water. The survival of aquatic life in such river becomes difficult. pH in our digestive system. Our stomach produces hydrochloric acid. It helps in the digestion of food without harming the stomach. During indigestion, the stomach produces too much acid and this causes pain and irritation. To get rid of this pain, people use bases called antacids. These antacids neutralize the excess acid. Magnesium hydroxide, a mild base, is often used for this purpose. pH change as the cause of tooth decay. Tooth decay starts when the pH of the mouth is lower than 5.5. Tooth enamel made up of calcium phosphate is the hardest substance in the body. It does not dissolve in water but is corroded when the pH in the mouth is below 5.5. Bacteria present in the mouth produce acids by degradation of sugar and food particles remaining in the mouth after eating. The best way to prevent this is to clean the mouth after eating food. Using toothpastes, which are generally basic, for cleaning the teeth can neutralize the excess acid and prevent tooth decay. Self-defense by animals and plants through chemical warfare. Honeybee sting leaves an acid which causes pain and irritation. Use of a mild base like baking soda on the stung area gives relief. Stinging hair of nettle leaves inject methanoic acid causing burning pain. Some naturally occurring acids. More about salts. Family of salts. Salt with the same positive or negative pole are said to belong to the same family, such as NaCl and Na2SO4 belong to the family of sodium salts, same as NaCl and KCl belong to the chloride salts. Salts of a strong acid and a strong base are neutral with pH value of 7. On the other hand, salts of a strong acid and weak base are acidic with pH value less than 7, and those of a strong base and weak acid are basic in nature with pH value more than 7. Some samples of salts, solubility in water, estimated pH, salts acidic, basic or neutral, acids used, bases used. Chemicals from common salt. The salt formed by the combination of hydrochloric acid and sodium hydroxide solution is called sodium chloride. This is the salt that you use in food. It is a neutral salt. Seawater contains many salts dissolved in it. Sodium chloride is separated from these salts. Deposits of solid salt are also found in several parts of the world. These large crystals are often brown due to the impurities. This is called rock salt. Beds of rock salt were formed when seas of bygone ages dried up. Rock salt is mined like coal. Common salt, a raw material for chemicals. The common salt thus obtained is an important raw material for various materials of daily use, such as sodium hydroxide, baking soda, washing soda, bleaching powder, and many more. Let us see how one substance is used for making all these different substances. Sodium hydroxide. When electricity is passed through an aqueous solution of sodium chloride, it decomposes to form sodium hydroxide. The process is called the chlor-alkali process because of the products formed, chlor for chlorine and alkali for sodium hydroxide. Chlorine gas is given off at the anode and hydrogen gas at the cathode. Sodium hydroxide solution is formed near the cathode. The three products produced in the process are all useful. Bleaching powder. Chlorine is produced during the electrolysis of aqueous sodium chloride. The chlorine gas is used for the manufacture of bleaching powder. Bleaching powder is produced by the action of chlorine on dry slaked lime. Bleaching powder is represented as CaOCl2, though the actual composition is quite complex. Bleaching powder is used, first, for bleaching cotton and linen in the textile industry, for bleaching wood pulp in paper factories, and for bleaching washed clothes in laundry. Second, as an oxidizing agent in many chemical industries, and third, for disinfecting drinking water to make it free of germs. Baking soda. The soda commonly used in the kitchen for making tasty crispy pakoras is baking soda. Sometimes it is added for faster cooking. The chemical name of the compound is sodium hydrogen carbonate. It is produced using sodium chloride as one of the raw materials. The following reaction takes place when it is heated during cooking. Sodium hydrogen carbonate has got various uses in the household. Uses of sodium hydrogen carbonate. First, for making baking powder, which is a mixture of baking soda and a mild edible acid such as tartaric acid. When baking powder is heated or mixed in water, the following reaction takes place. Carbon dioxide produced during the reaction causes bread or cake to rise, making them soft and spongy. Second, sodium hydrogen carbonate is also an ingredient in antacids. Being alkaline, it neutralizes excess acid in the stomach and provides relief. Third, it is also used in soda acid fire extinguishers. Washing soda. Another chemical that can be obtained from sodium chloride is Na2CO3-10H2O. You have seen that sodium carbonate can be obtained by heating baking soda. Recrystallization of sodium carbonate gives washing soda. It is also a basic salt. Sodium carbonate and sodium hydrogen carbonate are useful chemicals for many industrial processes as well. Uses of washing soda. First, sodium carbonate is used in glass, soap, and paper industries. Second, it is used in the manufacture of sodium compounds such as borax. Third, sodium carbonate can be used as a cleaning agent for domestic purposes. Fourth, it is used for removing permanent hardness of water.